For a while in our history, there was a huge interest in developing alternatives to JavaScript because lots of people wanted to use JavaScript because it lets you write for just about every user in the world. But lots of people didn't want to use JavaScript because, by the creator's own admission, the design was rushed and it all solidified a bit too quickly. And JavaScript didn't get the necessary luxury of an early access, iterative beta phase where it ironed out the kinks in its design. So JavaScript is what it is. Some people love it, great, not taking anything from them, but plenty of people wanted an alternative. I think the first big success there was probably CoffeeScript, but there were plenty of others. Very interesting time in the web, lots of interesting research and new ideas about design happening. And then eventually, TypeScript came along, and my personal surprise, succeeded in fixing most of my problems with JavaScript. Didn't fix all the sharp edges, but it certainly felt like it gave you safety gloves. For me, it really transformed the experience. It made it sane, quite pleasant. I like TypeScript in a way I don't quite feel about JavaScript. So, what of all that interesting research into alternative languages for the web? Is there still a big enough problem to be solved, a big enough demand? Is there a big enough question to be answered? And my guest this week, Gabriel Nordeborn, would absolutely say, yes, there is. This research must carry on, and these ideas must be explored, and we have other things to say. That if JavaScript had had that luxury of more time in the oven, it would have looked similar to how it does today. Perhaps it would look similar to how TypeScript looks today, but it would definitely be different. If the TypeScript compiler authors had the luxury of occasionally saying, no, we're going to change the language here and there, they probably could have spent less effort on type checking all the edge cases and perhaps used that time on things like compiler speed or code analysis or other language niceties that make life a little easier here and there. And maybe in that alternate world where JavaScript had had more design time, maybe it would have looked more like ReScript. So what does ReScript look like? What makes it an interesting alternative to JavaScript that's familiar but different? What does it offer to those of us who just want to get the job done but would quite like to enjoy getting the job done a bit more? Let's ask an expert. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Gabriel Nordeborn. Joining me today is Gabriel Nordeborn. Gabriel, how are you?
I'm good, thank you. How are you?
I'm very well. I'm pleased to see you've got a guitar on the wall behind you. So
yes.
You're ready for, after this is done, you're ready for a jam session.
I'm ready, yeah. I used to have, I have an electric guitar and a bass as well, and they usually hang over there. But my girlfriend, she teaches at the university. She gets so many questions about whether she plays or not whenever she's lecturing. So I have to kind of remove them. So I figure an acoustic one it's fine, right?
Yeah, that can also look decorative, right?
Yeah.
Okay. So the shared video room, I hope you've got exclusive access for the next hour or so.
Yes. I hope so.
Yeah. We should find out. We've been interrupted by cats before, but never by humans.
Yeah.
Okay, so let's move on from music and spousal arrangements to ReScript, which is something I know a little bit about, but I'm going to get you to give me the details on. ReScript, it's something JavaScript, something OCaml. Give me the proper definition.
Yeah, so ReScript is a programming language that compiles to JavaScript. I guess that's the easiest possible way of explaining it. It compiles to JavaScript. It integrates with the JavaScript ecosystem. It integrates with your JavaScript tooling. It's essentially trying to be optimized JavaScript, and it's. Okay. So that's the easiest possible way of describing it, but it kind of approaches it from another angle than what TypeScript does, for instance, which is also JavaScript, but yeah.
Yeah, because I sort of feel, maybe tell me if I've got the history right here, but there was a huge interest in JavaScript, but not JavaScript languages. For quite a long while. I think CoffeeScript is the first one that comes to mind historically.
Yeah.
And it feels like that market has been chewed up a lot by
Yes.
the emergence of TypeScript.
Yeah.
So what does ReScript offer today?
So ReScript, comparing it to TypeScript, TypeScript is trying to type JavaScript, right? And TypeScript has, I mean, the reason that a lot of the compiled to JavaScript languages have kind of been eaten up or close to it is because TypeScript is pretty fantastic. I mean, it's pretty great at what it's trying to do. It's been wildly successful in bringing types into the JavaScript world. This is a community. I'm originally a JavaScript developer. I was around when Flow first came out from Facebook back when TypeScript was a thing, but not really a thing, kind of. And then
I remember the two competing for superiority, and I remember thinking neither of them would succeed.
Yeah. Oh, really? Yeah.
Yeah.
Yeah, no. I mean, looking back at that time, the what I remember is primarily two things. One, the feeling of I'm not from a typed language for starting out, so the feeling of catching bugs in the build, which was fantastic, and then also the feeling of the Christmas tree, that's the errors in the editor at every version upgrade, where they learn to type more of JavaScript in each version. And we would have, back where I worked at that point, we would have hundreds, sometimes thousands of errors, and this was like an effect of obviously of the type checker getting better and better, but still, like that was pretty taxing on the mind. So but to get back to the original question, like where TypeScript, where Flow is still around, Flow is still really cool. I think it's very effective and has worked out really well for Facebook, but they haven't really cared about it becoming mainstream, whereas TypeScript has really cared about that external usage. But TypeScript is essentially, in my view, then the idea that we take JavaScript, which we already have, and we still want JavaScript, right? And we want to make as little adjustments as possible in the actual JavaScript that we write. We just want to apply types on top of this. So we want to take something that already exists and then apply types on it.
Yes.
And that because JavaScript is the way JavaScript is, it's a language that's been around for a long time, that drives a huge part of the web, that explicitly doesn't want to break any backwards compatibility, because it would potentially break 10-year-old sites, 15-year-old sites that are perfectly fine and around and should work. Yeah. Right? That's the main goal. Because of that, JavaScript has evolved a lot as a language because it's so incredibly popular, but it hasn't really cleaned up any of the old kind of baggage.
Yeah, you get bugs in the spec. If you don't have this bug, you are not compatible with JavaScript.
Exactly. Right? Yeah. So you have to code the bugs, which I mean is kind of cool. I think the trajectory of JavaScript is just, it's amazing and really, really cool. And the engineering that goes into the various JavaScript engines to optimize and everything it's fantastic. But TypeScript is kind of trying to tame this beast, but they're also taking the approach of, we want to tame it just enough for it to be kind of productive for you. So our goal is not to make everything typed per se. We are fine with there being inconsistencies. We are fine with there being weird patterns that you can do that are pragmatic choices, essentially. So they're trying to go from the top and just apply this type system on top of JavaScript. ReScript is the idea of, what if we instead come from the side? We take something that's established. In this case, it's the roots are in OCaml, so we take OCaml in this case. Another entirely separate thing, entirely separate type system, conventions, everything, paradigms. We take that and then we try and mold that into something that comes as close to JavaScript as possible, without making too bad trade-offs, right? So,
and when you say mold it, do you mean, you don't just mean molding the output, you mean molding the surface language too?
Yes, exactly. Okay. Syntax, language features, the type system, a bunch of things. Try and make this move as close to JavaScript as possible, while not like throwing away all of the good things from the origins, like the sound type system, for instance. all of the speed of compilation, everything around that. So it's another angle at it. And what comes out of it is still JavaScript. It's very optimized JavaScript. Since it's a compiler, since we kind of made that trade-off, we can do a bunch of things that are really cool. Like we can rearrange even if you have a type definition of a user that has a name and an age, for instance, and then you define several instances of that inside of your ReScript code. And sometimes you let age come first when you define it, and sometimes you let name come first. Perfectly valid to do that. Yeah. But the JavaScript engines generally don't like that. They want things to be in a uniform shape so they can do optimizations behind the scenes with, I don't know all of the terminology, but shadow classes and whatnot. It's if things are always the same way that they were defined in JavaScript, it's generally beneficial to the engines.
Yeah, I can vaguely imagine like just-in-time compilation taking advantage of that kind of thing. Yeah,
and a bunch of caching and all of those things. Essentially. So what ReScript can do, since we already made the decision that this is a compiler, we're not like TypeScript lets you write annotations essentially on the code. But the idea is that if you remove all of these annotations, what you have is JavaScript, the same JavaScript that's going to run in the browser, on the server, or wherever, with a few like small deviations from that, like enums and stuff that aren't really JavaScript. But
by and large, TypeScript isn't trying to rewrite your code.
No, not at all. Exactly. It's very much trying to do the opposite. Just be the same thing, but with added types, essentially.
Okay.
And that's a trade-off. That's really good in certain situations as well. But ReScript, we've already made the decision that we have a separate compiler. We have a step that takes code that's something else than JavaScript. Although it looks very much like JavaScript, it behaves very much like JavaScript. Still, it's something else. And then we have a build step that produces the actual JavaScript that runs in the browser or on the server. And with that, we can do a bunch of things. Like, for example, going back to, even if we define in our ReScript code age first and name second and name first and age second interchangeably, what's output in the JavaScript is always name first and age second. So it always becomes the right shape, which is beneficial to engines. And this is something that you don't have to care about. You don't have to think about that. It's just done for you, essentially.
Yeah. Rewriting performance for free, which is what a compiler should be good at, right?
Yeah, exactly. And I mean, it's always a trade-off, because one of the main goals of ReScript is also to produce... We want to produce JavaScript that's as close to what you'd write by hand yourself as possible, right? And that's important because one of the biggest challenge that you face as a language like ReScript, where you're trying to make people not use the industry standard, make people, or use something else than the industry standard in addition to what you're already doing. We're starting with a lot of deficit in trust, right? We got to build up the trust and show that this bet that you're taking, we understand the bet that you're taking, and we're actively trying to work on it playing out well for you. So the part about emitting JavaScript that looks handwritten is a very big and important part of that, because
that would suggest to me that your target audience, because there are two potential target audiences for this that spring to mind: OCaml people that want to be in the browser, and JavaScript people that are lured towards the idea of OCaml, and that suggests you're looking at the latter.
Yeah, exactly. And not if you're interested in OCaml, that's great, and you're going to feel right at home with a few differences. But what we're targeting is JavaScript developers or TypeScript developers that want another type of, and in our view, then another web dev or JavaScript developer experience that makes other trade-offs than the things that they're currently doing, but that has a lot of concrete, very clear benefits and very many answers to problems that you face as a TypeScript developer at scale, essentially.
Okay, give me an example of a high-scale TypeScript problem that you solved. There are two things that regularly come out when someone starts using ReScript and then goes back to TypeScript, and one is compilation speed. That's a massive difference, and it's a pretty big problem in larger TypeScript code bases, and that affects both building your actual
application, or rather type checking it. Building it is incredibly quick because it's all about just removing the type annotations, right? So actually getting from TypeScript to JavaScript that runs in the browser on the server, that's fine. Because but validating that also type checks, that takes time.
Right. So it's developer experience rather than CI pipelines.
Exactly. Or like you want to type check in your CI pipeline as well, probably, but still. Yeah. And that also affects the feedback loop inside of the editor, for instance. Mm-hmm. It's pretty common in larger TypeScript code bases to have lags in auto completion, for instance, in hovers and everything.
Give me an idea of what counts as large. I mean, what size of project am I going to have to be at before this starts to become noticeable?
I think it's TypeScript is getting faster and faster and better, of course, as well. But it's still pretty noticeable. I notice things in projects that are around 100K lines, 50K. That depends entirely on what libraries you're using as well, and that's another part of this.
Yeah,
because the type checker is so advanced in TypeScript, which is really cool. Like the things that they've been able to do and let you do is amazing and fantastically fascinating. Like being able to build in an entire parser inside of the type system itself that can figure out, like it can type GraphQL, can type CSS, can type extract variables from path strings for or route strings and things like that. So it's amazing, but it comes with lots of pitfalls in performance if you don't know your TypeScript wizardry well, essentially.
Right. And do you have the equivalent then you're saying you have the equivalent in ReScript but faster?
No, we don't. So that's another point. So ReScript makes a very conscious choice of we're trying to be simple. If you contrast the ReScript type system with the TypeScript type system, the TypeScript type system can do virtually anything, almost. It can do so much. And you can wrangle it, and you can kind of make it molded into very many different things. Whereas the ReScript type system is much more simple, but also much more predictable, both in terms of how it works, but also in terms of speed. For instance, there are no larger pitfalls in terms of performance of type checking, for instance, like there are in TypeScript. And I usually I like to liken it with TypeScript is a massive amount of tools that you can do virtually anything with. And those tools are many in numbers, and they are usually kind of not super sharp, but you can combine them together to create almost anything. Whereas ReScript is a small toolbox that you can't do the same things in all instances that you can do in TypeScript, but the tools that you have in your toolbox are incredibly sharp and are well thought through to fit together very well. And this, in my view, and since I'm originally a JavaScript TypeScript developer, and I still spend a good chunk of my time in my day job to working on TypeScript code bases and stuff. What I miss primarily when I go to TypeScript is how many little things I have to do manually in order to achieve the same thing as in ReScript. Like how things
You're going to
fit
have
together.
to give me a concrete example of that.
Yeah. Of course. So one thing is immutability, for instance. Everything is immutable by default in ReScript. Yeah. There are great tools for using mutable values and working with mutable values, but you're never ending up in a situation where something's accidentally mutated. It's always an explicit action. That's one thing. Exhaustiveness checking when working with, in ReScript, I'd work with pattern matching. That isn't really a thing in TypeScript, but you can kind of force the compiler to have you within certain limits, make sure that you handle all cases, for instance, of the value of a string literal or whatever. In ReScript, that's done automatically always in all cases. So you always have to handle all cases, and the compiler's not going to compile unless you do that.
That's one of those features I really like when someone adds an extra case to the data, and then you've got to find all the places in the code base where it might affect things, right?
Yeah. And it's again, it's one of those things that's it's doable to a certain extent in TypeScript, but you kind of have to do it yourself. You have to either use a library that's tailored for it, which comes with its own kind of potentially performance issues and type checking performance issues, or you have to make sure yourself that you tell the compiler that I want you to make sure that this thing down here never reaches, essentially. So you have to move another step into it and kind of do the work yourself. You can do it, but you got to do it yourself. Whereas in ReScript, it's all built in.
Built into the language, yeah. Okay, those are two very good advantages. Anything else on the top list?
Yeah, so in ReScript, everything's an expression. So you can assign anything to a let binding, for instance. You can assign an if or switch to let binding. You can put expressions like switches or ifs or whatever anywhere in the code, nested inside of other code, and the kind of things that you can't do in TypeScript, where you'd have to use either ternaries, because those can be nested inline, right? Or you have to assign things to a variable or break it out to a function. And these things add up, especially around making your code kind of clear to understand and co-locating logic with where it's supposed to be. Like, for instance, say that you're deep in somewhere and you're submitting something to an API, and you have an object that you're submitting, and one of these props are the status of the current user or something like that. You have something else inside in your scope that you want to derive the status from. And in ReScript, you can just put your switch at that exact object prop, right? You can just switch right there and say that the current status of the user, as I'm submitting it to the API, is this switch. And then you switch on something else. Oh, it's online, then it's supposed to be this instead. Oh, it's offline, then it's supposed to be this instead. Whereas in TypeScript, this would have to be either a long chain of ternaries, because that's the only way to kind of put expressions directly in the code. It would have to be an immediately invoked function, because that will kind of give you a block kind of thing as well. Or it would have to be a variable, which is the most common thing that you do, or a function that you call. But neither of those are as good for maintainability and clarity as having the logic put exactly where it's supposed to be, where it's applied.
Yeah, I've often felt this distinction between like statements and expressions is very arbitrary and unnecessary these days. Yeah. So would you say then that ReScript is a functional language? Is it pushing people away from something like OO?
It definitely has its roots in a functional program. We're not trying to kind of advertise it as a functional program only, where you can still do lots of functional things in it. But we're trying to be pragmatic. Like, what we want people to build good stuff and to be able to use this for the things that it's good at being used for. So we're not trying to say that you have to do functional programming only if you use ReScript, but there's no denying that it's quite easy to do functional programming, and you're going to end up doing a lot of functional programming because there are no classes, obviously, and those types of things. So there's no OO in that sense. So yeah,
right.
But we're not trying to be dogmatic about it, I guess, is the point. Yeah.
If I had the equivalent program in JavaScript, I wanted to rewrite it in ReScript, I would not just be rewriting, but also rethinking how it was architected.
Yeah.
Okay. That's a pro and a con depending on where you're standing.
Yes, definitely. And that's the usual trajectory. Since I work a lot with people who are introduced to ReScript and usually come from JavaScript or TypeScript. I also spend a lot of time talking to the various companies that use ReScript in production to try and understand, like, what can we do better? What are you valuing? What's important for you? And those things. And the story I typically hear is that you introduce ReScript and it takes some time to getting into. It's another paradigm to what people are used to. If you come from another language that's similar, obviously it's going to be a lot more smooth sailing. But if you come from JavaScript and TypeScript, you're kind of used to doing things in a certain way. And it does take some time to kind of get up to speed with the paradigms in ReScript, where you will be working much more with functions. You'll be working with using pipes, for instance, to transform things and everything around that. But then when they kind of get over that hump and start getting productive in it, and then eventually come back to TypeScript, it's usually the same kind of experience that they find themselves missing the things that I stated, of course, and other things in a way that they hadn't really thought about before. Like all of a sudden, when they're writing TypeScript code or pure JavaScript, there are things like that I now have to do manually that I did perfectly well before manually, and I wasn't bothered by it. But now that I kind of know that you could potentially do this in another way, it's becoming kind of a hassle.
Yeah. I definitely think in programming there are some things that are obviously like better than what you've currently got, but there are some things it's like, why would I need that when I can do it myself? And it's only when you go over there and have the tool that does it for you, that you suddenly feel like the old way was primitive.
Yeah, this is especially a thing with like compilation speed, which is hard to kind of tell people that this is important, that the feedback loop is really important for how productive you are and how much focus you can have over how long a period of time. And I have a fun story with a project I was working on where we were using TypeScript for the backend and ReScript for the front end, and the front end built really quickly and incrementally built really quickly, and the backend started getting large, and it kind of built took maybe sometimes 7, 8, 10 seconds before you got things to kind of reboot and you had type checking and everything. And I worked together with a Java developer, and he was like, "This is so fantastically fast." the 7, 8, 10 seconds, and I was on the other end like, "This is so slow. I can't like." Yeah. I keep going to check the newspapers whenever I start compiling. So it's all about perspective, essentially.
Yeah, but it's definitely something you can get used to any compiler speed, but I think things get chronic when you find that you've often forgotten what you were doing before you started compiling.
Yeah. And that's a thing that I value a lot, and I've been reflecting on this a lot through the years. And for me, one of the most important things for me when programming is that I can stay in my focus, deep work kind of state as long as possible. That's where when I can like transfer idea to my editor in a quick way and stay in thinking in the system and everything without interruptions. That's when I do the best work, and when I can do much work for a long time. It's when I get slowed down or I feel friction around, oh, now I have to do that manually in order to just reach the next kind of step in figuring out what I'm supposed to do. That's kind of when I get much, much less productive than just the time it takes to do the things manually. Because it kind of wears out the enthusiasm for me in programming. And I'm very driven by being in flow state and kind of zoning out from the outside world and just digging into a problem, essentially. And I think that's
you want that constant interactive flow with what you're building.
Yeah, I want to be inside of the screen and just work on the thing I'm working on, and have all of these things float around here and think in the system and everything, working everything out, essentially. And I want to be in there as long as I can, because that's when things happen and happen quickly, essentially, with working. And so for me, it is like the feedback loop is incredibly important. Because the second that's too slow, it means I'm going to start doing other things and switch context and everything.
Yeah, and it's a small thing, but it actually has a fundamental difference on your experience of building something.
Yeah, and I very much believe that is a very important factor. Like originally, I'm a behavioral scientist, so I started out. I majored in psychology and experimental psychology. It's always like it's not therapeutic.
But that's not as exciting as it sounds.
It sounds much cooler than it actually is. It just means that I don't know how to treat people, but I do know how to do experiments, essentially. But I did a class in sports psychology or performance psychology that affected me a lot in my thinking, essentially, and it kind of ties into to this thing a lot and very well, in that your goal should be to get into and stay in flow state as long as possible. And for those who don't know, like what flow state is essentially when you're completely engulfed in or consumed by a task that you're working on. You know how you can sit down and essentially forget the outside world for a couple of minutes, an hour, even if you have the
you lose your sense of time as you're just completely swimming in the problem.
You're completely focused on just one thing. and you're focused deeply on that. And that's where, like, not all things that you do in programming is going to require flow state, but a lot of interesting stuff requires you to be in flow state in order to really, really think things through and work things through. And that's something that's what they work on in performance psychology and sports psychology, trying to figure out how do we get to flow state and stay in flow state longer. And I think like it resonates a lot with me in terms of programming as well. And maybe that's just how I work as a programmer, but I think like staying in flow state and getting to flow state, that's what the focus should be, because that's when you're doing your best work, when you're completely consumed in a problem.
Yeah. It's reminding me, for different reasons, I've kind of stopped using Clojure, but having a language that has a REPL where you're constantly in conversation with the compiler gives you that feeling. And I kind of miss that, actually.
Yeah.
Say it. But okay, so tell me how this is done in ReScript, because what's ReScript doing that TypeScript isn't to make this fast?
Yeah, so there's a bunch of things. Like, a lot comes down to the type system being much simpler and much more predictable, which means that you can optimize the compilation a lot more, for instance. But there are just so many fewer kind of things that the type checker needs to care about than what the TypeScript type checker needs to care about. It's also written in OCaml, which is a very fast language, great for building compilers, for instance. And that's been proven in the industry for long. The first Rust compiler was written in OCaml. OCaml itself is obviously written in OCaml. So it's a great language that's really fast as well. So that's obviously also a difference. TypeScript is written in TypeScript itself. Although, like, honestly, I would assume that it is a big factor. But these days, like, you don't know, you can write pretty fast JavaScript as well, and maybe it's not always whether the language is super fast or not that makes a difference in the end. Depending on what kind of tasks you're doing, of course, and stuff.
But does multi-threading play into it? Is the OCaml compiler multi-threaded?
It is now, but we're not using any of it. The compilation model, though, makes a big difference, because there are no like cyclic dependencies allowed inside of ReScript. There are in TypeScript, so you can always build up a tree of the most efficient possible compilation, where you start somewhere and then figure out, okay, now I need to do these things. And the compiler in ReScript works on each file in isolation and in parallel, so it can do as much work in parallel as possible, essentially. So it
can compile each file in parallel, you're saying?
Yeah. You invoke the compiler for each file. Yeah. So it's not multi-threaded in the sense that the compiler itself is multi-threaded, but it's you run the compiler in isolation per file, and you can do that in parallel, of course.
Oh, okay,
because it's stateless in that sense that what it does, it takes a file and then it produces an artifact from that file by using artifacts from other compiled files that it depends on and things. But it's
oh, okay. So it's compiling. Is it compiling some kind of binary, or is it compiling some kind of summary?
It's compiling a binary
version of the compiled thing. Is that incremental? If I then do I need to recompile if I haven't changed the source?
You need to recompile the things that, starting off from where you're triggering recompilation, you need to recompile the things that might have been affected by what you did, essentially.
Okay. So anything that imports the file I've just changed?
And then there are like a multitude of things that are affecting this. Like, you could have there are interface files in ReScript, for instance, where you can put your type signatures, and then that could speed up compilation by a ton, because you would only need to check internally that the interface still holds, and if the interface still holds, you won't need to do anything else, because this couldn't have changed, right?
Okay,
So
I imagine you've got, because to hark back to something I said earlier, it's like one of the big reason I thought originally that TypeScript and Flow would fail, I admit it, I was wrong, happily wrong. I thought they would fail because the scope of JavaScript, the language, designed as it is, untyped and with some documented specced bugs, right? The surface area of what a compiler for that has to do is so huge.
Yeah.
I thought they'd never be able to type check everything. Maybe it sounds like you're saying they can type check everything, but there are just optimizations they're not capable of making.
Yeah, I think they've gotten very, very far in terms of how much they can type check, but it's also a matter of type checking. How much can you figure out by yourself as a compiler? Like, how much can you actually figure out without having the developer have to tell you what types you're expecting something to be and those things?
Like inference.
Inference. ReScript has just like OCaml has fantastic inference, where depending on kind of how you design your program, you might not have to write any annotation at all, essentially. And this is another thing that's very important to me personally, because most ReScript code snippets that you look at, unless the person has wanted to annotate, is going to look much more like JavaScript than TypeScript, in the sense that there won't be a bunch of annotations around for, and it's still going to work. And that's a very important thing, looping back to the kind of flow state and those things, in that writing annotations, unless it's important for the task I'm doing, but writing annotations just for bookkeeping to the compiler is a manual task that does slow me down and cause friction, right?
Yeah.
So if I can avoid that, I can just focus on writing my code, understand that the compiler is going to help me. It's going to infer things. I know how I can make it infer things the way I want it to, essentially, and how to structure my code without having to tell it explicitly what everything is. Outside of the parts where I tell it because this makes sense for maintainability, it might be much easier to scan the code if I have a type annotation here, for instance, to tell it. If I can avoid that, that's another thing that's not going to slow me down and pull me out of flow state, essentially, or not allow me to get in it, because I'm going to be able to focus on writing my program and my logic, not bookkeeping for the compiler, essentially.
Yeah, because there are at least 3 flavors of type checking, right? There's type checking in order to please the compiler.
Yeah.
There's type checking for us humans, and there's type checking because there is a genuine argument about what's right.
Yeah. Exactly. Yeah. And that's another thing that people, when they come back to TypeScript, usually miss a lot, in that TypeScript, because of, like, again, TypeScript is fantastic, and it's amazing what they've been able to do. But the way JavaScript is, like, the task they have it's not super nice to type JavaScript, right?
I mean, so TypeScript people must have said, if only we could change this one thing about JavaScript, our lives would be easier.
Yeah. I would assume so. And also, like, they are, since half the world is using it, if not more, they're probably so incredibly swamped in just trying to figure out how to get to the next day, in terms of there are so many people using this, and all of these weird kind of problems surface because there are so many people using it. Essentially, like, how do we figure all of this out? So, like, they
must be terrific for finding bugs, but a bit of a headache.
They're probably going to find every bug there is, which is cool. But yeah, this is another thing that, like, when you come back to that, you're usually missing, and again, like, part of it is because TypeScript is trying to do what it's trying to do. It is very hard to infer what you're trying to do in JavaScript, because there are 10 different ways of doing everything in JavaScript, and there are very loose type rules around. You can use a plus for concatenating strings or adding numbers together, and a bunch of other things that, like, make it hard to type check without making a statement in terms of, we think this should be this.
Like, you're making me think of, like, I think I'm right in saying that string, if you've got a string that's a number, string plus an actual number has a different type result than number plus a string number.
Yes.
Depending on the order of the arguments to the plus operator. It's like that.
Exactly.
That's it. Yeah.
That is something I'm glad I don't have to deal with as a compiler kind of contributor, so to speak. But again, like, there are all of these things in TypeScript and JavaScript that's not TypeScript's fault at all. This is just how JavaScript works, right? It's just how someone made it back in the day, and that can't change because the entire, or half of the world at least, depends on it, so to speak.
Yeah.
And it leads to kind of all of these small paper cuts in, for instance, truthy and falsy values. Like, it's pretty common to use truth and falsy values for doing ifs in TypeScript, but sometimes you get tripped up by the rules, and you make a comparison that might not be the comparison that you're making a comparison that's not the comparison you think you're making, essentially. Yeah. And a little bug comes in there, and it's really hard to figure out at a glance. And ReScript is strict in the sense that you can't compare a string to an int unless you make the string an int or the int the string, essentially. You can't do an if on something that's truthy, whatever that means. And you have to make it on a Boolean, essentially. So it's annoying when you start out and where you're used to just being able to do a truthy check, for instance. But it kind of adds up as you move along and use the language for longer, because you don't have these kind of weird bugs anymore. And anyone who's worked with React Native, for instance, in JavaScript, especially back when, I don't think this is a problem anymore in the same sense that it was. But since not everything is an expression, like in ReScript, for instance, you end up either using ternaries or the and operator to kind of to do conditional rendering. And
right, yeah.
Yeah, and for those of us who work with UI, I'm originally like a front-end developer primarily. We know that building UI is just conditionally rendering stuff. That's all it is, right?
That happens a heck of a lot, yeah.
Yeah, so but if you don't have the tools for it, kind of weird stuff can sneak in. And back with React Native, the thing is like you use the and operator to kind of conditionally render something. If this thing is true, or truth in this sense, then return this other thing. Otherwise return undefined, which is the kind of implicit behavior. And in React Native, the app would crash if you tried to emit certain things inside of the text or inside of the React kind of element tree. And there was a common pattern people used where they would sometimes accidentally end up with zeros being emitted because of how the and operator works. Which would crash the app. And this has happened to me in production a bunch of times as well back in that. Oh. And that's also kind of thing that you have to pay the cost in that you have to think a little bit more about what am I actually comparing here when it's strict. But still, like, you don't have those types of bugs where what you're doing isn't really what you think you're doing isn't really what you're doing, essentially.
Yeah.
And it's kind of hard to at a glance figure out. Yeah.
It shouldn't come up because you should think more clearly every time you're using the operator. But if it's a thing where you need to be infallible as a human, the computer should be doing it for you.
Exactly.
Right?
Yeah.
Yeah.
And it's also hidden. Like it's because you have it's a variable that you do your and on, and in a code review or whatever, just looking at the variable. Yeah, I mean, probably fine, right? Whatever's in that variable in runtime, who knows? But essentially, yeah. So it's hard to kind of catch as well. But now there are lint rules for that as well, and I think it's been fixed in React Native as well. But that's one of those things that kind of, because you don't have the tools to do inline pattern matching, which you might have wanted to use in this case instead, you end up doing this other kind of method, using this other kind of method that's really not safe, and really not. You don't fully understand how it's working, but it's working as you want it to in 90% of the cases, or 95%. But then the 10 or 5% case comes along and kind of ruins your day, and alarms go off, and you have to wake up and go fix things and submit to App Store. And
you don't want to program by workaround if you can avoid it.
Exactly.
Okay, so since you've mentioned React Native, I want to move on to this because. What's the story for interacting between ReScript and things like React Native, Vue, any JavaScript library? What's my interop story?
Yeah, so one of the goals of ReScript that we're working towards is that this should be as interoperable as we absolutely can make it with JavaScript. So today, if you want to try ReScript in your TypeScript JavaScript codebase, which is something that we very much think that we don't want you to think that, let's throw everything out and just use ReScript. No TypeScript, no JavaScript. Like, there are perfectly valid use cases for using just JavaScript or using TypeScript. We don't care about whether it's that you're using it only or using it together with other things. We want to make it as easy as possible for you to just get started and use ReScript together with everything else. Okay. So it's a single npm package that you install through your regular kind of npm workflow. the compiler, and then you set up a config file and the ReScript file, and then you compile, and it spits out JavaScript in a separate file that you can just import inside of your TypeScript, and the other way around.
Okay.
You can import JavaScript and TypeScript by writing bindings from the outside world. So integrating your ReScript inside of your TypeScript or JavaScript app is a 5-minute thing, essentially, which is one of the very important things for us.
Okay, so to make sure I've got this, for ReScript to JavaScript, it's emitting JavaScript anyway, so that's fine.
Exactly.
For JavaScript to call JavaScript from ReScript, I need to annotate the types in ReScript syntax.
Exactly. You need to write bindings for them, which is a pretty easy process, and something that we're because this is one of the hurdles that's left for us, like figuring out the binding story well. It's always something that trips up people who are new, but once you kind of learn the ropes, it's pretty convenient and easy, and you can write bindings easily for most things. But still, it's something that we really want to improve to make that story better as well. And when you go from ReScript to JavaScript, you obviously just use the JavaScript files that are emitted. They will look roughly the same as the other JavaScript you have in your project. But when you want to go to TypeScript, there's also built into the compiler a way of generating TypeScript types from your ReScript. And that's also something that we're working to. It's working really well today already, but we have a few tweaks we want to make to it to make it even better. And that means that you can export things from your ReScript file and get actual TypeScript types and typed experience from TypeScript. So, but the Interop story with we want to make it we want to be a part of the JavaScript ecosystem. We want you to be able to use anything from npm and everything. Currently, you have to write bindings, of course, but other than that, it integrates the JavaScript you produce is you send that into your build step, you send that into Vite or Webpack or whatever it is that you're using. It's all inside of the normal workflow that you have. For React and React Native, we have a good experience around JSX. It's first class in the language, so it's actually built into the parser itself, native support for JSX.
Oh, okay.
And we've spent a lot of time making the Interop story with especially React as good as we can. So I know that there are lots of people who use it with React primarily, but also with React Native. So that works well. In terms of Vue and Solid and Angular and stuff, we some of it is usable in a good way if it's using JSX. But things like single file components and other things that Vue has, for instance, and other tools as well, is currently you have to kind of compile your ReScript to JavaScript elsewhere and import it into your single file. So it's not the seamless experience that you'd have in normal Vue, so to speak. And again, it's something that our goal is to be perfectly interoperable with JavaScript. So this is something that we eventually want to solve. But what we've also realized is that we need to focus on selecting a number of use cases that are important and then do them really well. And that means that we focus our energy on those, and then we will get to everything else also, eventually. But we have to start somewhere. And again, going back to us being in a trust deficit when you want to introduce us instead of an industry standard at some place. We need to make sure that the experience of doing that introduction is as good as it can be. So we try and be focused on a few use cases and then master them, and then we move on to others as well. Essentially,
that's fair for a project with finite resources. That's fair.
Yeah.
It makes me think then that it sounds like one of your big targets that you're actively working on is React. Don't know where the name dropped from my head there. React and React Native. Would I just use it for the front end, or because you said you were on a project that was ReScript on the front end, TypeScript on the back end? Could it have been ReScript on the back end?
Yes, very much so. But again, moving back to the use cases, I use ReScript in a number of projects on the back end as well. I know several companies who use it on the back end as well. But going back to focusing on single use cases, we focused on the front end first, essentially. Mm-hmm. But it's all just JavaScript, right? So you can use it in the back end perfectly fine. It's just
What am I
you're
going
not
to
going to.
miss? Am I not going to find the type definition bindings of popular libraries? Is that?
Yeah, exactly. You're going to find less ready-made bindings essentially.
Okay. That doesn't sound like too big a deal.
Yeah, it's not too big a deal, but it's also like the matter of the kind of ecosystem thing. So you'll find less like ORM bindings, database stuff, like those types of things. Although I've been trying to work on that as well. I have several projects again, like that uses Postgres databases, SQLite, all of those types of things, and does it in a pretty nice and typed way. But it's a matter of that part of the ecosystem not being built out as much as the front end has been. Essentially.
So it is an ecosystem thing rather than the language itself.
Yeah, there's not like. In terms of ReScript and interoperability with JavaScript, there's nothing lacking, except that it would be nice to kind of have generator functions or something closer to that, like better iterator support, which you use more in the backend than the front end. But still, like there's nothing missing in terms of that. It's more a matter of ecosystem, I would say.
Okay, that makes me wonder things like async.
Yeah.
Do you have async support?
Yes, we have native support for async await, the same as in JavaScript.
Okay.
So it's the exact same thing, with a little twist. So the cool part about async await in ReScript is that you can switch directly on an await expression, and you can handle actual promise rejections through handling exception rejections in your pattern matching, essentially. So
okay.
So that's another thing that's kind of a unergonomic, or not as ergonomic as it maybe could be in JavaScript, that in order to handle like using async await, you have to wrap your await in a try catch in order to catch that potential promise rejection. And then you have to either use var for the scoping, or you have to have a predefined let variable to assign the await result to. But if you have a predefined let variable, seeing as TypeScript can't really infer what it is, you have to type it right away what it's supposed to potentially be, right? So there's lots of steps involved. But then you have your try catch, and you can handle promise rejections and things. But in ReScript, what you would do instead is you'd write a switch for pattern matching, and you'd await your value directly in the switch, and then you could handle the promise rejection as a JavaScript error, which is the same thing that you're doing in try catch inside of as just a branch in the pattern matching. And what's emitted is still a try catch, the same thing that you'd write by hand in.
Does that mean I'm going to get exhaustiveness checking for the error side of async code? You'll get exhaustiveness checking for that. And there's also another interesting thing that we haven't built out as much as I would like, but that we'll also get to eventually, is there's a tool called reanalyze in ReScript, which is a static analyzer for your entire code base that can detect dead code, unhandled exceptions, where you might end up with exceptions that you haven't handled, and that type of thing. And that is a really cool thing that I also miss immensely whenever I go back to TypeScript. Because the background for reanalyze is that since the ReScript type system is sound, in the sense that if it compiles, all the types agree, and all of the positions in your files have actual types, right? So there's no ambiguity in the types themselves. You can always figure out exactly what something is at a position, as long as it compiles. Okay. Yeah.
So given that, and given how kind of records in ReScript works, where it's a nominal kind of shape, reanalyze can figure out things like, everything from like, this value, this function is never used, to this function, this argument in this function is optional, but it's always applied everywhere. So you could make it not optional if you wanted to. It can figure out, you have this record. Let's take the user example that I used before. Name is a string and age is an int, for instance. You have this user record. You're never actually reading the name field here, so you could just remove that. Nowhere in your app are you reading your name field, or the other way around. Like, you're never actually constructing. If you have a variant, for instance, and you have multiple constructors for that variant. This variant you're never constructing.
Okay, that's quite advanced.
For instance. Yeah, it's advanced, and the big thing that I use it for is it makes cleaning up stuff so much easier, because you can literally go into Codebase, switch that on, just get thousands of errors probably around like things that are dead or and then you can just go through it and remove one thing at a time, remove, and just understand things, find things that we've like I regularly find bugs around. Oh, this thing that I wrote a helper here, but I forgot to use it. For instance, oh, that's a bug. Like I probably had an idea with writing that, those types of things. And that's been an incredible help. But it's also cool because you can kind of build tooling on top of that, because ReScript can figure out, or Reanalyze can figure out exactly what from a record that's actually used throughout your entire program. Doesn't matter if it's in the same file or if it's passed through a number of files. It's still going to be able to figure it out. So for example, I use GraphQL a lot, and I have a ReScript project called ReScript Relay, which is bindings to it's going to be very front-end now, but bindings to Facebook's Relay GraphQL client, which is a very advanced and, in my view, a great client for building UI, essentially. And the big thing in Relay is that you kind of co-locate your data dependencies with the code that's actually using them. So you write GraphQL fragments. Sorry for everyone who's not familiar with GraphQL, but still, you write fragments where you essentially say that, oh, this code down here, it's using... it's selecting fields from the user, and it needs the name and it needs the age, and maybe it needs the best friend and the ID of that and the age of the best friend, something like that. So you kind of
it's almost listing which bits of data you export, right? Yeah,
exactly. So it's kind of like I like to liken it with, it's like the component model, but for data. Essentially, you have you define your kind of props, and then you select those, and that's what you end up with getting inside of your components. So you define your data elements. You say that we're working on an avatar component here, and I want to render the name, obviously, in the avatar. So I select the name and I select the avatar URL from the type user from my API. Fine, like that works well. But then I stop using the name. I no longer need a name. Like I just need the avatar URL. I remove the hover or whatever on my avatar. Now I have to remember to also remove that selection from my data, right? Otherwise, it's going to overfetch. Like in this case, it's not going to be a problem. Obviously, it's just a name, but still, like you could potentially forget to remove selecting heavy fields that are like expensive to compute and those things.
I have definitely seen this in startups where they go through the first couple of years, and the product has evolved a lot and changed a lot, and we have no idea which bits were old experiments that have actually long since died.
Exactly. Yeah. And this is like this is the type of thing that I just love, in that this is what happens in reality, right? It doesn't matter how smart you are or how used you are to building stuff. It's the same with me. I've built a bunch of things around this tooling. I should be very mindful around removing things I no longer use. I still find stuff all of the time that I forgot to remove, and old experiments and whatever. So like it's again like to what you said, like the machines have to help us with this, right? We need help.
They are diligent in a way we can't be expected to be. Yeah.
And honestly, don't want to be. Like, I want to be in my flow state, and then I want someone else to come and clean stuff up, right? I want to do like what I'm good at, and then have a bookkeeper come in and fix that or whatever. So this tooling bit, what it can do, thanks to the type system being sound, for one, so that if it compiles, everything has a type. You can trace any type throughout the type system. Thanks to that, and also thanks to Reanalyze and a couple of other things around GraphQL. There's a CLI in the ReScript Relay project that can take your entire all of the selections inside of your GraphQL and figure out, is this actually used inside of your application? Are you accessing this anywhere, this type? And if not, it can automatically remove those things from your GraphQL selections. And you can put this in CI, which means that you'll never ever ship any overfetching from production, right?
Oh, nice.
So that's one of the things that is it's I think it's cool technically also, but it's also like for me as a developer and as someone who needs to care occasionally about not fetching too much about servers and whatnot, like it is massively useful in the pragmatic sense, that this makes a difference in the real world, so to speak. And also what you mentioned about old experiments and stuff. That's also one thing that we regularly get feedback on when people start using Reanalyze in their code bases. Oh, this old thing, we kind of been a while since I see this. Obviously, we don't use that, but it's also important for newcomers that there's not a bunch of code lying around that they try and understand that's no longer actually.
Yeah, it's all mental overhead that you didn't need to spend. Yeah, as well as network bandwidth and everything else.
Yeah. So like to wrap up this long sidetrack on Reanalyze, the cool thing that we want to explore more with it is that since it can track exceptions also, like, oh, here's code that might raise an exception, you haven't handled that exception anywhere. Please either tell me that you don't care about handling it or handle it. That's kind of what Reanalyze can do. It can do that same thing for promise rejections, right? So it can do the same thing for async await. Make sure that you've handled every possible potential promise rejection as well. Something that's pretty hard in regular JavaScript or TypeScript to kind of do and track.
And definitely something I would want done. There's too much programming just for the happy path.
Yeah, exactly. And that's I guess, like one of the main criticism of async await, that it's very easy to do happy path things. It's hard to do error handling because you have to, in JavaScript, then wrap it in a try catch, for instance. And that it's again like it's both more code, but it's also another step that you have to take that people are gonna not take because if I can do less work, then that's usually good as well, right? So people are gonna forget about it. It's gonna slip through reviews and everything. But so what we're trying to do there is given the things I talked about in using a switch on the await and stuff, it's much easier to handle the case, like the errors as well. So we're trying to make async await slightly better as well in ReScript. In addition to it emits an actual async function in JavaScript and actually waits and stuff. So
yeah, because this is why I like to use typed languages, because I want to get my problems up front. If there's going to be a problem, I'd rather find out today.
Yeah.
Unlike most of the rest of my real life, but in that one respect.
There's one time I want this
to. Yeah. Okay, so I have to ask, I have to dive behind this because I'm curious, because you said you were a JavaScript, TypeScript reactor.
Yep.
Tell me about your journey going from that to now being something of an OCaml compiler tweaker?
Yeah.
How deep are you in, and how did you get there?
It's a long story. So like I've always been very technically interested, so to speak. I made a decision early in my life to use Linux, and which meant I got to move system files around while my friends got to play computer games, which I couldn't play because the state of Linux back then wasn't really good. Essentially. And I enjoyed that still. I enjoyed the technical parts. There's nothing quite like the feeling of power from moving a file inside of the terminal, especially if someone else looking that doesn't know how to do it. You immediately end up as the hacker.
You feel like a proper old school hacker.
Like the world is my oyster is my feeling after after doing that. But so I always started, like, I enjoyed that. I did, you mentioned the guitar back here. I did a lot of music production back in the day as well. And I decided to use open source tools for that, which was really cool. I got to be in a very cool community, which is the Linux audio community, filled with brilliant people who are very good at digital sound processing and very driven by the open source kind of thinking and everything around that. Amazing time. But then so I at that point I learned to help out in open source projects, not by programming. I did some programming too then, like back when PHP was a thing and you made guest books in MySQL and those types of things. Back when CSS wasn't a separate file, it was always attributes on the DOM node, essentially. So
I think the pendulum's swinging back that way at the moment, isn't it?
Yeah. I love it. All my knowledge is certainly it's coming back. But so I helped out with debugging various C++ programs for crashes and stuff, to try and help out. And I always liked it. I always enjoyed the technical parts. But then when I came to choosing what to study for university, I had this kind of angel devil kind of thing where it's like, oh, sure, you can go and be an engineer, and that's the obvious path, and you'll be stuck at that computer the rest of your life. You want to do that? Sure, go ahead. But I actually ended up choosing behavioral science instead. So, like I mentioned, so I studied psychology. Essentially, but then towards the end of the program, the devil kind of switched sides and was like, "Oh, but you have all of this like interest in technical stuff. Are you going to throw all of that away? Like you should just you should do something that's like tailored towards combining technology and behavioral science, essentially." And back then, UX and UX wasn't really like, it started becoming a thing, but it wasn't really a thing like it is today. So that wasn't an as obvious path. So I did kind of a web experiment in my master's that led me into working with WordPress and PHP and stuff. And then when I came out into the job market, there was 2 jobs as a behavioral scientist and like 2,000 jobs as a developer, so to speak. So I kind of got into that from the side, and I always known that if I get hooked on programming, I'm probably gonna enjoy it very much. Like it's very aligned towards like what I like to do. Again, the flow state stuff and everything around building stuff and thinking about things is nice, right? But also like thinking about things that actually, I'm not theoretical in the sense that I like to think about theory too much. I like to think about how to do things in the real world, so to speak.
You want the brain food, but the kind of brain food that leads you actually seeing a real world result.
Yeah, exactly. So I'm very much a product engineer, so to speak, and I still am. Like I'm very much focused on, I want to build things, and I want to build new stuff. I want to understand what users need, what they think they need, and so on. That's very much my focus. Okay. So I got into programming, and this is now 10 years ago or so. 11 years, and just slowly moved deeper and deeper into it. And as I told you, I kind of ended up, I used JavaScript, and React came out. I was using Angular before. My first impression of React was, I never want to use this ever. This looks terrible. And then I ended up using it. Like it ended up being fantastic. That was like, I don't think it was a too uncommon view of React back when it came.
Yeah, we must learn as programmers not to absolutely trust our first instinct.
Yeah, just super judge right away, right?
Yeah.
But yeah, as I moved deeper into JavaScript, I saw Flow and TypeScript. But back then, Flow was the thing. Like TypeScript wasn't at all as good as it is now, of course, but not even. It wasn't close to Flow either. Back then, Flow was really Facebook had all of this hype around React and everything in open source, and they came with Flow, and that was kind of universally what people looked at, essentially. So I started looking at Flow, and I had the experience I told you about before, that, this is so nice. I can see things before it kind of, I get paged in the middle of the night. I can see things in the build step instead. Yeah. And there are nice colors in the editor, and it tells me right away what's talking to me, kind of. Yeah, was my experience. But again, like I didn't have any experience from type languages before, right? In a larger sense. So the fact to have something like a compiler tell me what's wrong was an experience that was really nice, and something I hadn't really had before. The browser console used to tell me what's wrong otherwise, right? With big red, blah, 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 and define is not a function or those things, right?
Yeah.
But someone actually telling me inside of my editor, that was a new experience. So I started moving into Flow, started using Flow for all the things. Again, TypeScript wasn't a thing back then. And then came ReasonML and BuckleScript, and I started looking into that. This must have been around 2018 or 2019 when I first got into it. Started looking into that. Started looking into like the parts of OCaml I needed to understand to kind of understand what ReasonML was and what BuckleScript was, and kind of thought that, okay, if I take a few steps back and I look at what this is compared to what Flow is and where Flow is going, this thing, ReasonML and BuckleScript, looks much more like the thing I would want this other thing to eventually become, right? Inference, strictness, pattern matching, variance. It just felt like this is the end game for this other thing, for me, at least, essentially.
Yeah, I can totally appreciate that.
Yeah, so that was kind of my entry to it, and then as I started trying to work with BackendScript and ReasonML, I hit a major wall, which is, I don't think, uncommon. Still not uncommon for people coming to either languages. But speaking of ReScript, it's not at all uncommon that people come in and they hit a wall. And my experience was kind of, okay, I know all of this JavaScript. I think I'm pretty good at JavaScript and Flow then back in the days. Here I'm in a new language. Everything looks cool. I can read code. It's readable. I understand when I read it. I don't know how to filter or map an array. Like, how do I do it? I have no idea. And I look in the docs. Still doesn't quite click for me. So I had an initial hump where once I got over that, I started seeing the light, essentially, and everything, all of the benefits. But I did have a major hump, so I'm pretty glad that I stayed with it and tried to understand things a little bit in depth. But that was my prevailing experience, and that experience is something that we're trying to. It's always going to be there in some certain sense, right? It's another paradigm. You are going to hit you might. Some people make it over perfectly fine.
But the odds of hitting that point where all the stuff you've got a familiar pattern in your short-term memory for, you've got to relearn that stuff in a different way.
Yeah, exactly. Yeah. And you're in the thing that bothered me the most is that I know all of these things. Like, I can build UI in whatever. I can work with the DOM. I can do this. I can transform data. I can do that in JavaScript. I'm not learning a new thing. I want to do these same things, right? But I just don't know how to do it in the language. And there's just no obvious, it's not clicking as fast as I hoped it to click, kind of.
Yeah.
So that's very much an experience I take with me, and where we work in ReScript to try and, again, minimize the odds. Like, you might hit a wall, but we're trying to make that wall much softer, smaller, and kind of less likely to actually be hit.
That raises one question, which is how?
Yeah. So many different small things we do to try and make that more. I have a very recent example that, let's hope I can explain this in an understandable way. But for those of you familiar, ReScript has pipes. That means that you take the result of something, or you take a variable, you take a value, and then you pipe that into a new function that you call with maybe some other arguments as well, and then you pipe that result into a new function. You get this nice long pipe chain that you would, the equivalent in JavaScript would be method chaining an array, for instance, where you have array filter, array, then you have a map, and then you have a join.
Blah.
Yeah, exactly, that thing. But in ReScript and in other languages that have the same functionality, you can do that with any function. It doesn't have to be something on the prototype. You don't have to wrap it around. Like, it kind of inverts how things look. If you look at an example, if you don't know this from before, if you look at an example, you're going to see right away kind of what it, how it simplifies things. And this exact same experience I had, where I had an array of something, and then I tried to map and filter that inside of what was back then in BackendScript and ReasonML. I like that same experience is very common when you come from JavaScript, because you usually map and filter arrays, right?
Yeah.
But in ReScript, you do the same thing. You can map and filter arrays. Don't worry, it all works. But you do that through piping instead. So instead of writing my array variable dot filter, you're writing my array variable pipe array dot filter. So you're calling a function through the pipe on the thing that you have. And this has the added benefit of it's actually pretty clear when you look at code, even though there aren't type annotations. You can see that, you're doing an array map because it says array map, right, inside of the code as well. Yeah. So it's nice. But discovering that thing and making the connection that what you did with a dot before is the same thing that you do with a pipe and the module name plus function, essentially. Making that connection takes time, and it's not obvious. But when you're in my back, Gabriel from 2018, and you try and do this filter, there's literally nothing helping you to figure out that you're supposed to write pipe array dot map. Nothing. whatsoever.
Maybe it's somewhere in the documentation, but that's hard to Google for as well, right?
Yeah, exactly. You're going to find it in the documentation. You're going to be able to dig it up, but there's nothing in my editor. There's nothing helping me out. There's nothing telling me that I can do this.
There's no immediate flow state feedback.
Exactly. Yeah. So I get stuck, kind of. Yeah. And we still we've improved things somewhat in ReScript by making sure that pipes, if you write a pipe, you get auto completion from the main module of the type that you're piping on. So if you have an array, there's an array module available that has all of the filter, join, and map stuff. So if you write a pipe after something that's an array, you're going to get completions from array and have array map, array filter, blah, blah, blah. Perfect. You can now see that these things exist. So that's one of the big things, and actually a developer experience thing that and we in ReScript are really proud of, because that makes you can also tailor that kind of to your own types and control autocomplete for your own types and make sure that the experience is nice for the developer.
Because that will also work when you've got a custom type with your custom library.
It'll look inside of and you can even, recently we've added that you can even configure your type to say that, also draw completions from this other module if this is the type that you're piping on, and draw it from, or these other two modules essentially. So you can have it draw from, and we plan on doing more autocomplete customizations essentially, so you can tailor your experience more to your project and stuff. But going back to, so we did that improvement, and that's good, that's great, that's helpful, but you still have to understand that you're supposed to do a pipe here if you want to do what you want to do. You're used to doing a dot. You have to understand that you got to write the pipe to get the auto completion right. So there's still a step left in order for this to be obvious. So what we've worked on now, and that's inside of our review or preview VS Code extension, is that now if you have your array variable, if you write a dot, you get completions, but from pipes. So we kind of taken the thing, the behavior that you're used to, and when you do that behavior, you're going to get completions. It's not going to be a dot. It's going to remove the dot and insert a pipe instead, and the thing that you select. But still, your way into this is still the same thing, or can be the same thing. The regular pipe still works, of course.
So you're actually explicitly generating LSP code actions tailored towards someone coming from a different language.
Yes.
That's the first time I've heard of someone doing that.
Yeah. See how much people like this, but it's for us that try to be pragmatic, try to understand our target group, try to make it as easy as possible to both sell this to your colleagues, sell this to your boss. It's so important that you have a good first experience, or a good first week, a couple of weeks, essentially, when you work with this. That's going to massively improve the chances of you sticking with it and keeping it around in your company and everything. We have to do what we can in order for this to kind of work out. And I use it still because it's one less character to type, and it doesn't really matter. A dot is one less than the pipe, essentially. So it's also that kind of thing. But so I think that's a pretty good example of what we're doing to try and make it easier. And it's again, I want to highlight that this is something that it's not changing anything in how the language works. If you leave that dot in there, it's still not going to compile. It doesn't change anything. It's just a tooling thing that can help you kind of understand things quicker without necessarally costing anything for the one who doesn't use it. Right? It's just an addition, so to speak.
Yeah.
And
totally.
Yeah.
But what? So I have to ask, what's your role in that feature? Are you the behavioral psychologist figuring out that we should do this? Are you the person hacking on the LSP server to make it actually work?
Yeah, the latter. The idea is from a great new community member we have who kind of it comes from redesigning the bindings to the DOM API. That's also been a major. We have some great open source bindings maintained by the community for that, but ReScript has evolved a lot since those were made, and there are a lot of new features that you can use in ReScript that makes it feels more idiomatic and makes the developer experience better. So while trying to figure out how can we do good DOM bindings in a more idiomatic ReScript way, we kind of hit a wall with there are like overloads and stuff in the JavaScript APIs, right? There aren't too many of them inside of the DOM API, but since ReScript doesn't have any overloads, you can't define multiple fields in a record, for instance, that points to the same underlying thing but has different types. You have to define a function instead that works on the main type, and that has like different functions for different overloads, essentially.
So you have to wrap the different overloaded versions in a kind of dispatcher.
Or rather, like you make distinct functions for each case. So if you have an API that can either take a string or an int, you could do two functions: my API string, my API int, and they would take either a string or an int, and that's how kind of they would bind to the same thing in JavaScript. They would emit the same JavaScript code, calling the same JavaScript method, but for the type system's sake, it's different functions, essentially.
Okay. Right.
So that's kind of how you model. And so we ended up in a situation where, okay, we have all of these things. We can't really model them like we would in a perfect world model them, which would be, so it looks the same as JavaScript. Like it looks, if you have an HTML button, for instance, you can do HTML button dot some prop on the button itself, and it looks the same as JavaScript, essentially. So we hit a wall with like, okay, we have a problem here. How do we make people understand that some of the things that you want is regular record fields that you get when you complete on the whole HTML button, but some of them are things that you want to apply on the HTML button from using the HTML button module with all of the helper functions, essentially. So with our overload, for instance.
Yeah.
Back to 2018 again, right? Like the answer's there. It's perfectly logical, but there's just no quick way of making people understand it and getting it into kind of their thinking. So Florian, the community member, he kind of said, what if we just make completion return pipes as well, in addition to figure out what from the main module we can apply on this to our overloads, for instance, like the functions that we want to apply, and just return that in addition to the record fields, essentially, or the fields on the button itself. So, and then I started hacking on the feature itself inside of the editor tooling, of course, and then eventually ended up shipping it a couple of weeks ago, I think.
Nice. So you really are getting really granular on the developer experience, not the language features.
Yeah, exactly. Yeah. And that's been the big thing with ReScript has been trying to figure out how do we move closer to JavaScript, the good part, so to speak, how do we make this better in terms of that, more idiomatic, move closer, cover more use cases, make it more familiar to JavaScript developers. And when I say that, I don't mean it as bring in everything that JavaScript has, all of the faults as well. Like, we're trying to be very picky about what we bring in and how we bring this closer to JavaScript. There's obviously a clear limit on how close we can get without eroding the nice things that we've inherited from OCaml, for instance. Like, how close can we get without destroying those things? We are very mindful of that. So we want to make it's pragmatic. It's driven very much by JavaScript and real world usage of JavaScript. But also, it's important. And we have many features around that. One of my favorite things that shipped last year, I think, is we have untagged variants. And the best way to explain that is that you can, in ReScript, to a certain extent, you can model all of these weirdities that you have in JavaScript in that something can be either a string or an number or a function or an object or an array at runtime, and you have no idea unless you check at runtime what it actually is.
Yeah.
And this is something that's been notoriously difficult to handle in ReScript before, because there's just no way to represent that, right? There's nothing like that in the language itself, because that's not a thing in its origins. So normally what you do is you either have unwrapping code that takes that thing, identifies it through JavaScript and figures out, okay, what is this actually, and then maps it onto an actual ReScript type. Or you just use ReScript structures, and that's going to be fine as long as it's internal in your app. But as soon as you end up working with the outside world, which you usually do because you use libraries and like API responses and whatever.
You're going to have to use third-party JavaScript libraries.
Yeah, exactly. And then you end up in a situation where you have to do all of this, again, manual bookkeeping that, this thing deeply nested inside of my API response might be a string or an int, and there's no way for me to handle that without making sure that I explicitly myself unwrap this at all times. So untagged variants is adds to the type system, and especially like the compiler itself, to be able to model this. So you can model a variant and say that this at runtime, this variant constructor is true. This variant constructor is the number 12. This variant constructor is an int. This variant constructor is a string. This variant constructor is exactly this string. And this variant constructor is a regex. This variant constructor is a function. Yeah, the list goes on, obviously, so that's been hugely helpful, because that means that the surface of what we could bind to idiomatically in ReScript and JavaScript kind of increased by a ton when we shipped that. Because there are, JavaScript is fantastic and it's wonderful, but there are a lot of weird APIs in JavaScript, right? A lot of maybe not fully thought through stuff still. Yeah, so we need a way to kind of handle those things. And what this led to is, of course, that we can kind of interact with much more of JavaScript, but also a side note, it led to us now being able to model JSON with just JSON with just language constructs. So JSON can now be it's just a variant, definition that has all of the potential, a recursive variant definition that has all of the potential values. So this is really cool, because this means that you can do JSON encoders just by using the language, and you get all of the kind of features, like all of the niceties of variants, by doing that, since it's all in the language itself. And so that kind of solved that. You could have your user, I come back to the user example, the user record, name and int, like you could turn that into something that's actually guaranteed to be representable as JSON by using the variant representation, right? For that, just taking your record and
Because I've found with like typed languages speaking to JavaScript that you always have this problem of serializing and deserializing JSON. Does that make my life easier explicitly?
It does make your life easier. Then again, like if you do a lot of serializing and stuff, maybe you don't want to handwrite encoders, decoders anyway. And there are other libraries also for solving it that helps you decode. But again, like you can write all of this just using the language. And what we added a couple of months back is we added pattern matching for dictionaries. So dictionaries in ReScript compiles to a regular JavaScript object, but it has its own dedicated syntax inside of ReScript, where you can kind of construct dictionaries with static keys and then add your own. And then now you can also pattern match on it. So you can pattern match on essentially a dictionary saying that, this branch should match if this prop has this exact value and this prop doesn't exist, for instance, or that kind of thing.
Yeah.
And that's, again, like in other situations that might not be super useful. In JavaScript, it's very useful because so many things are modeled as dictionaries in JavaScript, especially in Interop. And what this did is it kind of made the JSON support full circle, because this now means that you can write JSON decoders just using the language, because a JSON object is in ReScript represented as a dictionary of other JSON values, right? So now you can, if you have some JSON value and you want to check if it's a user, you can now pattern match on it being a JSON object that's a dictionary that has a name key, that's a string, that has an age key, that's a number, and so it kind of made it go full circle. And the cool thing about this, I think, then is that it's all native features in the language, right? There's nothing else to it, which is cool and kind of shows the potential in trying to come closer to the everyday kind of use of JavaScript.
Yeah. Okay, I'm very tempted to try this out now. Very tempted.
Yeah, I would love it if you did.
Is it production ready in your opinion?
Yes, definitely. It's been in production for a long, long time at many companies.
Okay.
We are like we're currently ReScript is currently at stable version 11.1, and we're working on version 12. And version 12 is going to have a fair number of changes compared to 11. We've kind of slowly made a transition towards where we want to be language-wise. And when version 12 ships, we've finally cleaned up a lot of things that has been like a lot of old kind of things that we've inherited that doesn't make sense anymore for us, as we're only targeting JavaScript, and made streamlined the experience more. So ReScript 12 is going to be much easier to get started with, and many less kind of holes to fall into that aren't really relevant for building things and so on.
Oh, so like you had some baggage from your OCaml days. Is that what you're saying?
Yeah, but baggage is we had some stuff that made sense when the idea was to compile to not just JavaScript. But I mean, baggage is a hard word. It's just not applicable anymore. Probably is more of a So we kind of taken the opportunity to kind of streamline things as well and make it more. Again, closer to JavaScript and to a good experience. 11 is still great, so like try it out. But it's getting even better in 12.
Okay. When do you think 12's coming without committing to a deadline?
We're aiming for Q1, so
Q1 2025.
We'll see. We're aiming for that, but we'll see what happens essentially.
So where do I go to get started? Give me the best place to start.
ReScript-lang.org.
Okay,
that's the best to get started, and we have a forum as well. It's linked to from the webpage. But I would encourage you to just go and try it. There's a playground as well on the ReScript Lang website, and again, like try a few things out. Just see if you can get some basic stuff going, and then if you're a JavaScript TypeScript developer and you don't have the experience from similar languages before, like stick with it for a while. I dare say that it's very likely that you are going to like it a lot. Like that is the experience that we have in the real world mostly. Like people don't want to go back once they're hooked, essentially. So stick with it. But there may be a hump, like to learn the new paradigms and everything. But
if you get there and you find you would never return, that's treasure, right?
yeah, exactly.
Okay. On that point, I think I'm going to go. I've got a couple of hours before I have to do some productive work after this call, so I think I'm going to go and kick the tires. Gabriel, thank you very much for joining me.
Thank you very much for having
12.
me. Oh, thank you very much.
Cheers. Thank you, Gabriel. If you want to try out ReScript for yourself, head to rescript-lang.org or find the link in the show notes. I have been using it a bit since we recorded that conversation, and I will say this for sure. The compiler really does feel snappy. They've done some excellent work there. Before you go and try it for yourself, if you've enjoyed this episode, please take a moment to like it, rate it, maybe share it with a friend or a social network. If you enjoy Developer Voices episodes regularly, please look for us on Patreon. Again, link in the show notes. And if you haven't yet started to enjoy Developer Voices episodes regularly, make sure you're subscribed, because we'll be back soon with another. But for now, I've been your host, Chris Jenkins. This has been Developer Voices with Gabriel Nordeborn. Thanks for listening.